आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. So today we are going to solve one question on differential equations. So now here in this question, it is given that we need to show that the given differential equation, that is the x square plus xy times of dy is equals to the x square plus y square times of dx is a homogeneous differential equation. And after proving that this is a homogeneous differential equation, we also need to solve it. So let us first consider this equation here. So here we are given the differential equation as we are going to put this dx on the left hand side and we get the dy by dx like this. So we get the dy by dx is equals to, here we have the x square plus y square whole divided by the x square plus xy. Now for proving this that this is a homogeneous differential equation, we are going to put this dy by dx function as the function capital F of x comma y. So here we assume that the capital F of x comma y is given by, here we have the x square plus y square whole divided by the x square plus xy like this. Now we are going to find the value of the capital F of x lambda comma y lambda. So here we have the value of the capital F of the x lambda comma y lambda like this. So instead of x we are going to put the x lambda. So here we have the x square lambda square. Similarly here instead of y we have the y square lambda square like this. And in the denominator we have the x square. So instead of x square we have again the x square lambda square plus xy. So here we have the xy lambda square. So now we can see that if we take the lambda square common out from the numerator and we can also take the lambda square common out from the denominator, then it gets cancelled out like this. And if we solve this again, then we get the x square plus y square whole divided by the x square plus xy. So now we can finally conclude that this function, that is the capital F of x lambda comma y lambda, here we have got the capital F of x lambda comma y lambda like this, and this is equivalent to the lambda to the power 0 of the capital F of x comma y. Now since here we have got this equation, we can conclude that this given differential equation is a homogeneous differential equation. So here we have proved that the differential equation, the given differential equation is the homogeneous differential equation. Now we are going to solve this given differential equation. So for solving this we are going to put the y is equals to vx. So now we are going to assume that the y is vx like this. So let us say that this is the equation number 1. Now in this equation 1 we are going to differentiate with respect to x on both sides. So if we differentiate with respect to x in this equation 1 on both sides, then we get on the left hand side we have the dy by dx, and that would be equals to, here we have, if we retain the v, then we differentiate the second term, that is the x, that is 1, the differentiation of x is 1, plus if we differentiate the first term then we retain the second term. So here we have the x times of dv by dx like this. So here we have got this equation. Now here we are going to put the value of the dy by dx as this. So we have the value of the dy by dx as the x square plus y square whole divided by the x square plus xy. So here we have the x square plus y square. So here we have the x square plus y square, and instead of y we are going to put the vx by this equation 1. So here we have the v square x square like this, and this is whole divided by, in the denominator we again have the x square plus xy. So here we have the x into y, and instead of y we again put this vx. So here we get the x square times of v like this. So now again we are going to take this x square common out, and if we take this x square, then this x square, this x square, this x square and this x square gets cancelled out, and we finally get our equation as, here we have the v plus x times of dv by dx. So here we have the v plus x times of dv by dx, and that would be equals to, here we have the 1 plus v square whole divided by 1 plus v like this. Now from this equation we are going to shift this v on the right hand side of the equation, and if we do that then we get the value of the x times of the dv by dx, and that would be equals to, here we have the 1 plus v square whole divided by the 1 plus v, and here we get the minus v. So now if we take the LCM, then we get the 1 plus v square minus v square, like this on taking the LCM, and in the denominator we have the 1 plus v. So this plus v square and minus v square gets cancelled out, and we finally solve this. Then we finally get the value of the x times of dv by dx, and that would be equals to, here we have the 1 minus v whole divided by the 1 plus v. So we have got this equation. So now we are going to solve this equation. So here we are going to separate the variable. So here we have the dv. So here we bring this thing on the left hand side, and if we do that, then we get the 1 plus v upon the 1 minus v, like this, times of dv, and that would be equals to, here we have the dx by x, like this. So now we are going to integrate on both sides. So if we do the integration, then it would look something like this. Now we are going to solve this left hand side. So for solving this, we are going to add plus 1 and minus 1 in this numerator. So if we do that, then we get the integration of, here we get, if we add plus 1, then we get the 1 plus 1, that is 2, and we also have done minus 1. So we have the minus 1 plus v, like this, whole divided by the 1 minus v dv, like this, and this would be equals to the integration of the dx by x, like this. Now we are going to solve this left hand side further. So if we solve this side, then we get, here we have the twice of the integration of the dv whole divided by the 1 minus v, and here if we take this minus sign common, then we get the negative of the integration of, here we have the 1 minus v whole divided by the 1 minus v, that would be the dv, like this, and this would be equals to, here we have the integral of the dx by x, like this. So we have got this integration. Now we are going to integrate this. So now here if we integrate this right hand side, that is the integration of the dx upon x, then it would be the logarithm of x. So here if we integrate it, then we get the logarithm of x, and that would be equals to the integration of this thing. So here we have the 2 into the integration of this thing. So this would be the logarithm of the 1 minus v with a negative sign here, like this, and here we also have one more negative sign with the integration of the dv, that is v, and we also have to add one constant of integration. So let us say that the constant of integration is the logarithm of c, like this, where this is the constant of integration. Now from this we are going to find the value of v, this v. So this v would be equals to, we get the logarithm of c, like this, minus the twice of the logarithm of the 1 minus v, like this, and here we also have the minus ln x. So here we have the minus ln x, like this. So this is the value of v. Now in the starting we assume that the y is equals to v times of x. So from this we can get the value of v as the y by x. So now we are going to substitute this value of v as y by x in this equation, and if we do that, then we get this as the y by x, like this, and this would be equals to, here we have, now we are going to use the property of logarithm. We know that the logarithm property says that the logarithm of a minus the logarithm of b minus the logarithm of c, this would be equals to, here we have the logarithm of the a whole divided by the b by c, like this. So now we are going to use this property here, and if we use this, then we get the complete logarithm of, here we have the c, that is a constant of integration whole divided by, here we have the 1 minus v whole square, like this, into x, like this, and here we have also used one property. We know that the a times of the logarithm of b, this would be equals to the logarithm of b to the power a. This thing can raise to the power of this thing. So here we have also done this. So instead of this thing, we have written the negative of the logarithm of the 1 minus v whole square, like this. So from this, by applying this thing and this identity, we have got this thing. So now if we solve this further, and if we take the anti-logarithm on both sides, then from this we get the e to the power y by x, like this, and this would be equals to, here we have the c whole divided by 1 minus v, and the v is y by x. So here we have the y by x, like this, whole square times of x. So now we are going to solve this ahead. So now here if we solve this denominator, and if we take the LCM, then we get the c whole divided by, in the denominator we have the x minus y whole square, whole divided by the x square like this, and here we also have 1x. So this x cancels out with this x, and if we solve this again, then we get the c times of x whole divided by the x minus y whole square. So we have finally got the e to the power y by x. Here we have the e to the power y by x like this, and this is equals to, we have got this thing. So this is the cx whole divided by the x minus y whole square like this. So from this we can finally conclude that the x minus y whole square, if we shift this term to the left hand side, then we get as the cx into, and we are now going to shift this e to the power y by x to the right hand side, and if we do that, then here we get the e to the power minus y by x like this. So now in the question they have asked us to solve the given homogeneous differential equation, and here we have solved the given homogeneous differential equation, and after solving this we have got this result. So this is our solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।